So what I'm going to do now is I'm going to share with you some information about the MRT project in Kuala Lumpur. And this is one of the reasons I've ended up living in Malaysia. So we came back to Malaysia because we wanted to have raise family here. My wife's family are here, sisters here, we've got friends here with kids the same age as our kid. So we wanted to find a way to move to Malaysia. And lucky for me, the MRT were starting their second project, which is Line 2. And they wanted to use BIM to level 2, which is the UK standard for BIM collaboration. And it fit neatly into my skill set. So I applied for a job to work on the project and I got the contract and we moved to Malaysia. So I spent the last 4 years involved in this project and we're still building it. So this project's ongoing. So the project is at a very high scale. It's 52 kilometers in length. So it is going from the northwest to the southeast. The map's a bit rotated here, so you can see north is orientated in the in the corner. And the underground section, oops, go this way. The underground section, which is what we're going to talk about mainly today, there are 10 stations. So station 12 all the way across to station 22. And I'll give you some names of those as we go through, but you can see that this is the underground alignment through the city. It goes near the main hospital. It goes through KLCC, which you guys more probably know as Petronas Towers. It comes through Tun Razak Exchange, which you will all know about because of 1MDB and the scandal that's been racking in Malaysia. That's where the 1MDB scandal is at Tun Razak Exchange. It comes out through Chancel Inn and then it goes out through the old airport at Sungai Besi. So the underground section is 13 kilometers of tunnels. So this is the actual alignment in a graphical form. So the section away from the city is all on elevated viaducts. So it's up on bridge sections. And when it comes into the city, there are twin bored tunnels coming through the city and they're coming to connect into existing LRTs and existing underground networks. So this train alignment is designed to connect to as many other train networks as possible to create a connectivity system. And then once it gets to the south of the city, it then snakes all the way down towards an area called Putrajaya, which is the main government center, which is near the airport. So this is why it's such a long alignment. So it takes a long journey out of the city. Now, I'm going to show you the photogrammetric model. So this is actually a model that was generated in Context Capture, which is a photogrammetry software. And it shows you the locations of the stations in a 3D city environment. So you've probably seen something like this before. So here, there you can see the Petronas Towers in the foreground, and you can see the locations of the stations in the city. So we've used a combination of helicopter imagery and drone imagery to create a 3D model of the entire KL city so we can actually locate the stations in the city. So you get a better sense from this imagery of the scale and density of KL and also the locations of stations. And here you can see the last two stations at Bandar Malaysia. So you can see it's a very large project. It's probably one of the biggest civil infrastructure projects in the region. And to give you a sense of scale, I call this an ultra mega project. Mega project doesn't seem to do it justice. There are 46 stations in total. There's 10 underground stations. There's 36 elevated stations. There's 38 kilometers of viaduct and 13 kilometers of tunnels. So the elevated package has got 20 construction contracts. The underground is a single design and build construction project. And then there's a separate systems contract with 7 different contracts for things like security, escalators, platform screen doors, communications, etc. And then there are all these disciplines that have to be managed and coordinated across this project. Now, MMC Gamuda are the turnkey contractor for this entire development. So we are responsible for building the entire alignment. So it is an absolute massive undertaking. Now, for the underground section, the MRT specified BIM level 2 for the underground. So all of the stations underground have been designed using BIM. So here we are in terms of a project timeline, just to give you a sense of where we're at. So we started the project in 2015 and the detailed design was completed probably in the end of 2019. So a year ago, or little less than a year ago. And we're now in the construction works phase and we're 70% complete on the construction works. So we've still got a third of the construction works to complete. And our expectation is to be opening line 2 at the end of 2022. And hopefully the current COVID-19 doesn't disrupt us for too much longer, but if a worst case scenario, it will be opening in 2023. So that's the timeline. So we're about 70% through with construction. So what did the MTR do in terms of BIM, in terms of specification? So they specified that for the project, we had to adopt an integrated approach. So to achieve BIM level 2 or level 2 BIM maturity for the SSP line 2 design, for procurement, for project delivery, for construction, and for operation, maintenance, and asset management. So this is the perfect case study for anybody who wants to understand the use of BIM for design, construction, and asset management. So the first thing that you have to try and figure out when we were looking at this project in 2015 is, do we understand the scale and complexity of the project? And it's very, very hard for anybody to get their heads around the scale and complexity of this project. So you have to start working in teams to figure out, well, how complicated are the stations and how much work is one station going to be? And then you've got 10 of those, and then you've got to do the tunnels, and then you've got to do the viaducts, et cetera, et cetera, et cetera. So you've got to get some sense of the scale and complexity. Simply saying it's huge doesn't count for much. Once you've figured out how big and how complicated it is, then you've got to figure out what the deliverables are. So you have to go through the contract requirements and figure out, what do I actually have to deliver? What information do I have to produce? What information do I have to hand over? What information do I need to build? What information do I need to manage? What information do I need to hand on? Then you can start talking about the resources to manage and deliver the scope of works. So in our case, we went through this with the design teams, we went through this with the engineering teams, we went through this with the construction management teams, we went through this with the site management teams, the safety teams, and we worked out what we thought was going to be required to use BIM to manage and deliver the project. Now, I use this slide because some of you might recognize the imagery. Does anybody recognize that project?
West Kowloon.
Yeah. So the roof of West Kowloon Terminus was the big, bright, red, shiny pimple that everybody was looking at. And it was sitting on top of this gigantic elephant of an underground train station. And BIM was attempted to be used by the MRT to solve and figure out some very complicated issues, and it failed. It failed because everybody was too busy doing 2D drawings and no one was looking at 3D problems. And the MTR, God bless them, they all said, oh, I wish we'd used BIM earlier. I said, that's great, but now it's too late. Some people said, well, we used BIM, but the results were not what we expected. And then we said, well, okay, well, unless you guys specify BIM, it's not going to be done. And unless the deliverables are contractual, it's not going to be done. So unfortunately, we work in an environment where unless it's written in the contract, it's not going to happen by accident. So this contract was designed by AECOM and ADAS in 2 dimensions. And the only 3D design that was done was by Bura Happold and a little bit by ADAS to work out the geometry for the roof steelwork. And even then, it wasn't enough detail. And the contractors ended up doing a lot of work to figure out that roof. And they would have been better off spending the same money and effort working on the station design. But that's my opinion. So if you want BIM to be successful, it starts with the client. And in our case, in MMC Gamuda for this contract, it was the MRT. So they planned out the implementation of BIM, they specified it, and they audited the use of BIM throughout the project. We still have regular meetings with the MRT to go through what's happening with BIM on the project. So you need to have client direction, you need to have client involvement, you need to have client leadership, working with the design consultants and the contractors collaboratively. So some of you who responded to my survey earlier on mentioned BIM as a collaborative tool. That collaboration is between the client, the consultants, and the contractors. It's not between the contractors and subcontractors. It's not between the designers and the engineers. It's across the entire team, including the client for the project. If the client is not involved, if the client is not collaborating, if the client is not participating, you are not going to succeed. And then every project must have a clearly defined outcome from the process. So this is commonly referred to as an employer's information requirements. What is required? Who is going to produce it? When is it going to get produced? And who is going to check it? And then my favorite, the early contractor involvement is required to ensure projects are designed for offsite prefabrication. A lot of people want to do factory fabrication. They want to do all this kind of great stuff, but they don't want to get a contractor on board till they've done all that and they get a hard tender price. It doesn't work. So if you want true collaboration, you have to tear up the rule book when it comes to tendering and forget about low price tendering. You need to get the best contractor with the best experience and you need to get them involved as early as possible. So early contractor involvement is required if you want to have any success. So the MRT project is a design and build contract. So MMC Gamuda, as the main contractor, we appointed the consultants. When we appointed the consultants, in every one of the consultancy agreements for the architects, the engineers, the building service engineers, and the QSs, they were all contracted to use BIM process to produce coordinated, constructible, detailed drawing schedules and quantities. But it's really, really important that the designers are actually contracted to deliver BIM. So let me show you what it looks like in terms of a model. So this is one of the stations. This is Titiwangsa, and the station is in the, basically the middle of the image. Just to give you some references, if you've ever been to Kuala Lumpur, you may have seen the monorail. This is the end of the monorail line, at one end, and this is an LRT station, which is alignment. So this MTR station is designed to connect to the monorail, and it's designed to connect to the LRT. So let me show you a video of what that looks like. So here you can see the overall federated model, which is everything combined. And then what we're going to do is going to go through it section by section. So this is the architectural model. Now, a key issue here is we've only got architectural elements in the architectural model. There's no structural elements in the architect's model. It's a very important issue. The structural elements are all in the structural model. So here you can see all of the concrete components, D-walls, slabs, beams, piles, and includes all the external drainage, because that's part of the civils works. Then you get into the complicated systems for the MEP. So here you've got the air conditioning systems, electrical systems, plumbing and drainage systems, and fire sprinklers. These are all detailed and designed by AECOM. And then you've got the railway operation systems. These are the 7 different packages by the other contractors. So there's train systems, platform screen door systems, communication systems. Our job as the main contractor is to actually facilitate the coordination of all these different systems. So this is a federated model walking through, and you can see all of the different systems have been put together in this model. So you can see the tactile paths, you can see the signage, you can see the glass smoke screens, and this is actually a section through the station. So you can see the level of detail and level of coordination. This piece of software is called Navisworks. So Navisworks is a tool that we use to federate all the different systems together. And then we use this tool to navigate around and look for issues in the models. So this is one of the 10 stations. So here's Ellie's comment. We had problems knowing whether they actually know about BIM. Yeah. Once we hired them, we found out, apart from the QS and BIM consultant, none of them knew to use BIM. Yeah. So they just sublet the BIM back to our BIM consultants. Is there a way to identify where they actually know BIM or just saying to get the job? Brilliant question. So if you look at the latest international standards, there are requirements for how you procure services and how you check the competencies of consultants. And there are questionnaires which can get into whether or not they can do it. But in my experience, the only way that you can get the consultants to perform is you have to take a very simple stance. You have to take the stance that they are going to bullshit you in the procurement process and say, oh, yeah, can, no problem. Yeah, we can do that. We did that before. Yeah, no problem. So every consultant wants to win the work, and they all need the work because they're basically on a cash turnover business. None of them are making any money. They all need contracts to keep alive. So they're all going to say yes. So if you're a client, you have to work on the principle that these guys are going to say yes, but then you have to hold them contractually. And what we've discovered is you have to put it in their contract that all of their drawings have to be produced from models, and that they have to demonstrate that the drawings have been produced from models. And here's the trick. You have to provide them with a common data environment where they have to upload their models and their drawings. And it's very simple to check if they've done it correctly. So if I open a Revit model, I can very quickly determine if they've done the drawings in Revit or if they've got somebody else doing it. And by making it contractually mandatory for architects and engineers to model first and draw second, you will eliminate BIM consultants, because most BIM consultants are doing what I call a backwards BIM process by going from 2D documents into 3D models. And that doesn't work, because as soon as the consultants change 2D drawings, the models are useless. So the answer to your question is none of them have got the right experience. They're not going to get the experience to keep giving it to BIM consultants who don't know how to do design. So you have to write in the contract that they have to do modeling and they have to generate the drawings from the models. And then you have to find some way of policing it. So if you've got a good BIM consultant, you should basically prohibit them from working for the designers in a modeling function, and you should use them as an auditing function to make sure that they're doing the work, and the BIM consultant should be doing all the training. It goes back to the matrix of what's important. If you don't train the architects to do it, or they don't do the training themselves, they're never going to get it figured out. So Ellie, you are in the majority. Anybody who specified BIM on any project in the last 10 years has got very positive responses from the consultants saying, yes, we can, yes, we can, yes, we can. And then they get in the job, oh, well, we don't have the resources. Oh, we don't have enough time. Oh, we don't have the right software. And then you find out that they're using a team in Philippines or a team in India or a team in China to convert their 2D CAD files into 3D models, which is completely insane. So I think that covers the topic, yeah. And every consultant's playing that game. Now, there are some consultants who've got some brilliant teams within them. So if you're lucky, you might get to work with some of the better consultants. But I've worked in AECOM, I've worked in ARIPS, I've dealt with ADAS, I've dealt with Björn Happold, I've dealt with all the major architectural engineering firms. There are brilliant people inside those companies that know how to do this right. But unfortunately, the way we procure design services is we go looking for the best fee, which means the lowest margin. And all the consultants are fighting to the bottom. And the problem is, in the current procurement for design services, they're reducing their fees, they're reducing their fees, they're reducing their margins, and all that's happening is they're reducing the quality of the output. They're doing less drawings, there's less detail on the drawings. So if you looked at drawings that came out of an architectural practice 20 years ago, and you looked at the drawings coming out of an architectural practice now, and you printed them out, take an MTR station in Hong Kong. If you looked at the MTR station drawings for the first line in Hong Kong, and you looked at the architect's drawings and you looked at the current architect's drawings, you would be amazed. There's a lot less drawings now, and there's a lot less detail now. And that can only be put down to the fees and competitive fees. So that's my piece on the architects. So here's another example of the complexity. So one of the challenges with any project, but particularly with major infrastructure project, is the number of interfaces. Down one side, you've got all the operating systems for the trains. So things like ventilation systems, power supply systems, then you got safety systems. And then along the bottom, you can see you've got all of these other systems, right? And then you've got architectural systems like ceilings, you've got SCADA, then you got drainage systems. And when you go back up the other side, you've got environmental control. And on top of all that, you've got things like the structure, you've got the other systems. So all of these interfaces have to be figured out. The challenge is, each of these systems is designed by typically different engineers, different firms. This is what a station that is carved up looks like. So you have basically a structural model, you've got the building services models, and you've got the architectural models. Now, we didn't just do the stations, we did the ancillary structures, we did the tunnels. All of the stations on the underground have been done like this, right? So from a very high level, the team were successful in building the models. But the problem was getting them to this point. So this is what they look like after 18 months. The problem was getting to this point. So let's go through some of the issues. So the first issue was getting everybody to use a common data environment. So if we go back, these are your responses to the questions earlier on, and it's in here all the time, right? Collaborative medium, right? A tool to gather and organize information, right? And a platform that makes it easy, right? So you guys understand comprehend what's required. So let me show you the common data environment that we used. The first thing is we call this a single source of truth. So the common data environment is effectively Windows Explorer on the cloud with a layer of security. That's all it is. It's nothing more complicated than that. It's nothing more sophisticated than that. It is essentially folders of drawings, folders of models on the cloud that everybody's got secure access to. And it's the only place that they can get access to the models, okay? So the issue with these platforms is behavior. So for Arrow1, to give you an example of it, we have over 700 users on the platform, right? So we got 700 users, right? We have 75,000 files, right, of models. There is 2.3 terabytes of data, and there's 250,000 drawings, 35,000 documents, right? So all the information is there. Challenge is, how do you know what to look for? How do you find it? How do you make sure you put it in the right place, et cetera, et cetera, et cetera. So what we're trying to do is we're trying to avoid the scenario on the left, and we're trying to promote the scenario on the right. So in the current industry, everybody's talking to everybody else, but nobody's got a clue what's going on. When you start using a common data environment to exchange information, everybody puts their information on the central system and everybody goes to that central system to get information. So if you're the QS and you want the latest architectural drawings, you don't call up the architect and go over to their office for a coffee. You go onto the central system and you take the information from the central system. So we're trying to cut out all of the one-to-one interactions and make them one-to-central. So this is basically a simple graphic which explains how this works. Now for our project, we have design consultants in Singapore. We have design consultants in Hong Kong. We've got design consultants in the Philippines. We've got some in Taipei. And we've got offices in India doing MEP modeling and MEP coordination. And all of these companies and all these locations need access to the information. So this needs to be a global platform. So what it does is it creates a single source of truth. We use common formats. So we use Revit, we use Navisworks, we use IFC, and we share the data frequently. So we have a rule that every week the architects, the engineers have to upload models. We don't care if they're finished, if they're half finished, if they're nearly finished, if, oh, I just need a few more hours. Every week there's a deadline and we want to see them sharing the information. And what we're getting at is that the early communication, it's easier to fix problems the earlier we see them. So we want to see progress, we want to see the models, but we want to keep an eye on the design progress. So the key issue here is that you start to collaborate in the true sense of the word in terms of collaboration. So the information that's being shared for this project, all the models, all the visualizations, all the review reports, all the coordination issues, all the drawings, all the schedules, all the links to GIS, I'll explain that in a couple of minutes, and all the data for facility management. And you're basically going, well, that's everything. I'm like, yep, that's everything. So all of the information required for the project is supposed to be stored on the CDE. So what we've done is we've set up a couple of basic principles. The first one is that this is a single source of files, right? So anybody who's working the project, if they turn around and say, oh, I don't have the latest architectural model, we're going to point them to the CDE. Oh, I haven't seen the latest structural drawings, we're going to point them to the CDE. Oh, I can't remember what they discussed at the last workshop, we're going to point them to the CDE. So everybody has to start working through this collaboration environment. So we've killed Dropbox, we've killed WeTransfer, we've killed OneDrive. All those single collaboration systems have all been eliminated or outlawed on the project. We're only using common compatible formats, Revit, IFC, PDF. So you have to put up those formats. It's frequent and it makes early communication essential. And then we have a layer of access management. So only certain users have access to certain information. We have a layer of version control. So every revision of every model is controlled. And sometimes we use workflows. And then we use this condition of statuses, which I'm going to explain to you in a minute in terms of pass 1192. And eventually we get to collecting data for facility management. So here are the statuses that get used in pass 1192. And essentially there are 4 statuses that people have to follow. Work in progress is what you do in your office. So if you're doing architectural design, you're doing that, it's called a work in progress, and you do that in your office. When you're finished doing a certain amount of design or a certain amount of progress, right, you then share that information on the common data environment, right? And once you share something, you're basically saying that that's reliable design information, that it can be used for coordination, it can be used for commenting, and it can be used for ongoing design development by others, and it includes any major versions or any major revisions. So when you share information on the common data environment, you know it's going to get used by other people for their purposes, okay? So this is really important that you share stuff that other people can use. Once the sharing has been done and everybody gets happy that they can move on, then they go to the documentation phase, okay? So this is what we call published information. So this information has been coordinated and is validated for the use for tender, for contractors, for manufacturing, for construction. So in other words, this is issued for a purpose. So once the sharing has been signed off, it could be for tender. It could be to the QS for costing. It could be to the contractor for building. But you move the information from a shared state to a published document stage. And then once that has been built and has been audited and has been signed off, then you archive that information. And the archive is a record of all the information that was collected on the project. So you only have 4 different conditions for the information. It's either in progress, it's been shared for collaboration, it's been published for action, or it's been archived for record. That's all you have to worry about. There's nothing else that you have to be worried about. So people get all fussy about, oh, I've got all these different statuses and I've got all these different conditions. And like, all you got to worry about is, are you working on it? Has it been shared? Is it used for publication? Now, the first thing that you have to get your head around is that you have to have a regimental structure. So the common data environment is not going to work if it's a random collection of folders and everybody's got their own folder. So what we've done for this particular project is we've set up a standard folder structure. And here you can see an example. So you have a project level, you have a MRT line level, you have a contract level, and then you have a station level. So this is Bandar Malaysia North Station. So even I don't know the name of the station, I know what the code is. So Bandar Malaysia North Station. And then I've got the discipline for architecture. And then under the architecture discipline, I've got a 2D drawing folder, I've got a 3D model folder, and I've got a PDF folder. Okay, so the 2D drawings are CAD, 3D models are IFC models, Revit models, and then I've got PDF renditions, okay? And it doesn't matter if I open up any other consultant's folder, they will look exactly the same. So every discipline folder is the same on every station, on every part of the underground. So even though I've got 35,000 drawings, if I'm looking for a drawing on a station for a discipline, I know exactly where to go looking for that information. So everybody has the same folder structure. And it's been clearly laid out as to how they're supposed to use it. So there's an explanation of how you're supposed to use it. And then we train people how to go through these different statuses. And we explain it step by step. So for example, for the MRT station, if I have a building services model, say an air conditioning model, I will link to or reference the structural model from the shared information on the system. If I need the architectural model, I'll get that from the system. So if I'm the mechanical engineer, I will go to the system and I will get the structural model and the architectural model, and I will get their shared models, and I'll use that for my coordination. So if I'm a mechanical engineer, worst case scenario, the architect's model is no more than a week old, and the same for the structural model. So I know I've got the latest coordination information available. Once I've gone through and checked that, I can then share my model. So I can share my model for other people to use it. And here you can see an example. This is the OWC. This is the Other Works contractor. So this is the guys doing the systems. So in this case, it's the electrical systems for the train. Just examples, so you can see the transformers and the cable trays, right? So this is the model by the OWC. So I can use that, and I can use that for my coordination. And once I've done my work, I can then publish it. So that's what we're going through, is going through my work, what I can get from the structural engineers, mechanical engineers, what I can get from external contractors, and then I can get to publication. Now, again, going back to the essence of celebrating certain successes, this is Nick Moorcock. Nick is the BIM manager for the whole of the underground. He's responsible for all of the BIM and all the BIM processes on the underground. He's also been responsible for getting BRE certification for PAS 1192 for this particular project. So Nick and his team, and it's quite a large team, have been very successful in actually getting accreditation to PAS 1192. This was one of the KPIs in the MRT contract, that we would get accreditation from a recognized body for the project. So again, because of the work we've done with the CDE, because of the work we've done with the models, and because of the work Nick's done with his team, we've received an international recognition for the work. So again, this is not to brag. This is a way of us showing you how we motivate our staff and how we make sure that we breed success in the organization.